Welcome, everyone, to yet another event from the Allied Talk series. This week promises to be truly enlightening as we delve into groundbreaking approaches to inclusive and empowering design in Dr. Cooper's talk. As the director of the Human Engineering Research Labs, Dr. Cooper takes us on a journey into the world of participatory action design, a methodology reshaping the landscape of engineering technologies. Stay tuned as we explore innovative ways to ensure these technologies meet the diverse needs and preferences of individuals with disabilities.
Hello everyone, good afternoon, and welcome to our very first event of the Allied series for this semester. For those of you who don't already know, I am Farheen Zubair, the Allied Project Manager. This group advocates for discussions around disabilities and helps promote awareness. I would like to take this time to welcome our very special guest for today, Dr. Rory Cooper. His list of achievements are a prestigious, never ending list. And with this, I would also like to, before I get into his achievements, I would like to welcome our founder, Dr. Minkara. Thank you. Without whom we wouldn't be a part of this great initiative. I would also like to thank someone who's assisting us today, our ASL interpreter. Welcome, Valerie Shirley. And thank you to all our wonderful audience for taking your time. Please grab a boba or some snacks before we begin our event. So it's an honor to welcome a distinguished individual whose impact on the field of engineering and rehabilitation is nothing short of remarkable. Our esteemed guest for today is none other than Dr. Rory A. Cooper, a U.S. National Medal laureate who was awarded the National Medal of Technology and Innovation by President Joseph Biden in 2023. Dr. Cooper is a trailblazer in his field, having earned his BS and Master's in Engineering degrees in Electrical Engineering from California Polytech State University and a PhD in Electrical and Computer Engineering from University of California at Santa Barbara. As the founding director of the Human Engineering Research Laboratories, a collaborative effort between the University of Pittsburgh and U.S. Department of Veterans Affairs, Dr. Cooper holds the distinguished position of a VA Senior Research Career Scientist and the FISA Foundation Paralyzed Veterans of America Distinguished Professor at Pitt. With over 400 peer-reviewed journal publications and 30 patents awarded on or pending, he is the author of 2 books, Rehabilitation Engineering Applied to Mobility and Manipulation and Wheelchair Selection and Configuration, and co-editor of several influential works. In October 2023, Dr. Cooper was honored with the National Medal of Technology and Innovation by President Biden, and he was inducted into the 50th class of National Inventors Hall of Fame. Today, Dr. Cooper is here with us and will share his insight on his talk title, Forging a New Future, Participatory Action, Design and Engineering Technologies with People with Disabilities. As he dwells into the groundbreaking approach into inclusive design, I could go on and on about his achievements. But without any further ado, let us welcome Dr. Rory A. Cooper to the virtual stage.
Thank you for that kind introduction. Thank you, everyone, for being here today. I look forward to speaking with you. Hopefully, we'll have enough time for questions at the end. In the meantime, let me just share my screen. And are you able to see my screen?
Yes. Yes, Professor.
Perfect. We'll go to slideshow mode. So I will give you a little quiz at the end of what does the post-nominative title in my PLY mean. You can look it up or try to guess. So let me start to show you a video about her.
In the United States alone, 1 in 7 people that has a disability of some kind that impairs their activities of daily living And technology has tremendous potential for improving the lives of people with disabilities. I was serving in the Army as a sergeant in Europe when I was injured, and I came home with a spinal cord injury and had to use a wheelchair. And there was like an 80-pound behemoth that I could hardly get in the car. I realized that there were a tremendous need for improving technology, improving the environment, and improving perceptions of people with disabilities. When the opportunity arose to work with the University of Pittsburgh and the VA Pittsburgh healthcare system, it was natural that we'd start HURL.
The laboratory, our mission is to improve the quality of life for people with disabilities through advanced research or engineering, get people more integrated into the community and to make them more independent. We do this through some of our programs that we have here, whether it's educational or research or outreach.
We started out as a wheelchair lab doing sort of manual wheelchair work and have expanded over the years to include brain-computer interfaces, robotics, virtual reality, cognitive aids, home modifications, and training.
The system that you see behind me, that's called the CAREN system, or the computer-assisted rehab environment. We work with people who have gotten prosthetic limbs. So in terms of how are they adapting to a newer technology, one of the latest technologies that's come out from University of Pittsburgh is the brain-computer interface, a robotic arm directly getting signals from the brain. So we're trying to see if we can get that technology, use it to drive wheelchairs much more efficiently, not just control left or right.
We have a machine shop where we can basically fabricate anything mechanically or electronically that we wish. What's kind of unique is not too many university programs allow you to do the design, but also do the fabrication and take you through all of those steps.
This is our robotics lab. Everything you see here has something to do with robotics.
We developed this called a Strong Arm, which is a robotic-assisted transfer device. This mounts to the wheelchair, folds up behind them.
We've developed ones mainly to replace upper extremity function for people, and then we're working on ones that can actually lift the person.
I think 10 years down the line will be something you would see used quite frequently and have tremendous impact on people's lives.
I was in the United States Marine Corps for 15 years. I was medically retired after being injured in Iraq.
Many of our people in HURL are themselves veterans, and many of them work clinically in the VA.
Press that bottom button until that says set.
I ended up here through an internship program called Elevate, and this program was designed for people to transition from the military back into academics who have any type of interest in assistive technology, engineering, and research.
Since our inception, we wanted to include veterans with disabilities in HURL as employees, as trainees, to reach out to them.
The experience I had transitioning through the programs here and the work that we do here really put a passion and fire inside of me to give back to the community, not only the veteran community, but others with disabilities like myself.
Research is continuously evolving as we can adopt new technologies and information from other fields of science that have influenced us. The end goal for us is full autonomy and full participation in society as equal partners and respect for people with disabilities. So I think we have a lifetime's worth of work ahead of us.
We taught from day one, we're not doing anything for charity, we're helping people to be themselves so that they can do better. You're not taking care of people, you're helping people take care of themselves.
Great, well, I hope you enjoyed that. And let me get into our presentation. So first, our philosophy is sort of based on the National Council on Disability, which is one of the independent federal agencies that advises the president. And, basically it's in a nutshell, nothing to be done for us without us, or nothing about us without us. But it even goes a step further that, people with disabilities have a lot to contribute. So one of the themes I hope you learned from my talk is that, for example, if you see the cover story here, which I'm circling, that's Dr. Brandon Davler and Dr. Jonathan Duvall, both that are scientists and engineers here at HURL, and they're among several of our scientists and engineers who themselves are people with disabilities. We use a participatory action design and engineering approach. And so Joe Olson is another one of he's a former scientist. He now works for the federal government. Ian Rice, another one of them. Our research is largely driven by user need. As people, I commonly ask people, and they say, how do you know what problems to work on? And I tell them my problem's not that. I have millions of problems to work on, just which ones do we work on first? And we do surveys and focus groups. We use storyboarding techniques. We use gather expert opinions, journey mapping, user testing, user acceptance testing. And of course, one of our goals is to have engage users throughout the entire process, but even more so to design and do research with users, not for users, and incorporate them into our team. So some of the things that are the focal areas that we currently have are 4 technology areas, and the other one is sort of broader participatory action design and research. This is driven by a large survey we did of about 1,500 people across the United States. And you can see advanced wheelchair design, smart devices applications, human-machine interface, assistive robotics, and intelligent systems with some sub-areas there. I'll talk a little bit more about our MeBot up in the upper left corner, a bit about our new chair and the exciting work with that. I probably won't go to the BCI work, maybe just a little bit. We're also doing some stuff on autonomous vehicles and transportation systems. Matter of fact, this morning I got the opportunity to attend a meeting with Secretary of Transportation, Pete Buttigieg. So that's very exciting. We also have done our meta-analysis, and through that meta-analysis, we identified 5 sort of global challenges facing individuals with disabilities. Living in the community, travel and leisure, health and well-being, education and employment, and then back to the action design and research. And our goal is to sort of address that through 4 different domains: voice of the consumer in the process, creating a creative learning environment, product innovation environment, and leadership and standards. Through that meta-analysis, we also learned about these 7 different technology areas that are a high priority for individuals with disabilities. If you're looking for areas where individuals with disabilities feel there's no need for greater research and development, these are some of them. So let me just go into some specific kind of areas. And one of the things that we're fortunate to have in the human research laboratories is a test lab where we do destructive testing of wheelchairs and prosthetics, walking aids, and other devices, where we test them on like a multi-drum machine where we can test door thresholds, sidewalk cracks, things like that, potholes. We drop wheelchairs, we swing things into the footrest, into the armrest. Through that, we've developed technologies such as the oblique angle suspension caster fork, also known as the glide. Also identified areas such as for need of repair, such as a frame component from a manual wheelchair. And here you can see a Meyer-Kaplan survival curve analysis, where we've got, we took wheelchairs like you see in hospitals or depot wheelchairs, your lightweight wheelchairs, which you might be using for temporary use. Unfortunately, titanium ultralight wheelchairs and our aluminum ultralight wheelchairs. And this gray vertical line is actually the FDA standard for passing. We test, these are hundreds of chairs tested that are already on the market. And as you can see, most of them actually fail prior to getting to the gray line, which is a little bit disconcerting. And so we continue to do testing and standards development. We've also done a lot of work on wheelchair ergonomics. For those of you students, I developed the Smart Wheel as a graduate student. It's still in use today as an ergonomics tool. Smart Wheel pictured on the upper left here measures the forces applied to the hand rim. We used it also last year to help our U.S. Paralympic team win some more medals in wheelchair racing. So those are the glove prints of Tatiana McFadden, one of America's top wheelchair racers, on the Smart Wheel. And if you look at the little graphs on the lower left here, what you can see is a person with the axle too far back, so too far posterior to the shoulder, and you see a little impact spike here. Try to circle that, and you see a person going at 1.4 meters per second with more strokes. We move the axle further forward. You get rid of those impact spikes or transition spikes. You get more area under the propulsion curve. That's the moment about the z-axis of the force tangentials and push room. Person actually goes faster with fewer strokes per minute. We related this to using ultrasound images. So here's a little stainless steel marker we placed on people's skin with a little bit of colostomy cement and tape. And then that shows up in the ultrasound image below as these two gray vertical lines. And that allows us to index the bisect tendon. And we did pre and post basketball games, pre and post wheelchair rugby games, pre and post a sort of a strenuous obstacle course that we created. And we were able to show that better ergonomic push rooms, lighter weight individuals who were lighter weight, and also moving the axles forward with respect to the shoulder, reduced bicep tendon swelling. We also did ultrasound. This is the median nerve as it goes through the the flexor retinaculum of the wrist, which is related to carpal tunnel syndrome. You can see actually the flattening of the radial nerve there, and that's a common sign of indication of pressure for carpal tunnel syndrome. So it shows that both the wheelchair setup is poor wheelchair setup can cause injuries in both of those areas, and that proper wheelchair setup can help reduce those injuries. So one of the things that I think is most impactful of this research is 30 years ago, about 80% of wheelchair users develop carpal tunnel syndrome or rotator cuff injuries within 5 years. Now that people have a tendency to get better wheelchairs and better wheelchair setups, it's only about 20%. Part of the reason is this research led to the development of ergonomic push rooms. These are the natural fit and the surge, two of the products that resulted from this research. What's exciting to me is that those patents have expired, yet the products are on the market. More importantly, other companies have now brought similar or knockoff products to market. Other one of the things we looked at is reducing the force on the downhill side when going on sidewalks, when you have some drainage for the sidewalk, water to drain off into the street, by having a little device that attaches the caster to bias the wheel forward. So you can sort of click this down. These are two magnets. It could also be a spring-loaded device that, and it helps. Actually, the cool thing is convert also wheelchairs to one-arm drives, which tend to be bulky and hard to use. A lot of people also just use it for like carrying a hot cup of coffee from the kitchen to the dining room table, for example. And these are some images of the patents on the side. We've looked at also the impact of vibration exposure on people and wheelchair users over the years as well. And Dr. Kuntz in our lab is looking at the in-wheel suspension using Kevlar spokes in a standard wheel, soft wheel suspension, which are basically 3 shock absorbers between the rim and the axle, and then the loop wheels, which is all really like 3 prosthetic foot blades used in a wheel design. Turns out that the standard wheel with the Kevlar spokes does a pretty good job of reducing the small vibrations that people see, and that the suspension wheels do a reasonably good job when you have a curb drop off, and suppressing those shocks and vibrations. But they don't do as good job of just regular small vibrations. We've now that more people use hand cycles as a form of exercise and sports and recreation, people have started developing carpal tunnel syndrome. So we work with colleagues in Europe who did some ergonomic analysis, and we then created this ergonomic hand cycle pedal that allows the the pedal to be spaced in and out so that the shoulder, wrist, and elbow can remain in a neutral position, which reduces the risk of elbow tendonitis, carpal tunnel syndrome, rotator cuff injuries. We also, you can see part of it is the handle is 15-degree from vertical, which helps keep the wrist in a neutral position throughout the entire stroke cycle. And then we remove the knee. We have this little bridge, and that allows, you don't have to have the axle go through the fingers like on many push rims, allows you to get a more comfortable grip. And then we have a palm handle that's 3D printed, so that can be customized to each individual and simply screwed into place. And then we can lose the shoulder adjustment in and out. And these all can be done independently, so you don't have compound adjustments. So I mentioned that wheelchair propulsion and now hand cycle propulsion, we can look at those as mechanisms for reducing upper extremity injuries. But important as well is the looking at transfers. So Dr. Kuntz on our team has been looking at using the Microsoft Connect system as a way to collect transfer data in the home and community, and also to use the transfer assessment instrument, which is a validated instrument we created about 20 years ago, maybe 15 years ago, used widely in the clinic to assess transfer skills, and to apply this in a non-clinical setting. And so we can help improve transfers. As a good friend of mine, the famous scientist, David Gray, once said, not what people can do in the clinic, but what people do in their home and community. Well, along those lines, Adam Struzala and Dr. Kuntz have been looking at how do we increase muscle mass in individuals with spinal cord injury, and also bone density, so that we reduce the risk for bone fractures and maintain muscle over time, or rebuild muscle after acute injury. And so they're studying a hormone, irisin, and how that can help with those. So currently we're in the data collection phase. So I just want to introduce this study and let you know at least we're looking at it. It has been shown to be effective in other populations. With some luck, it'll be effective in the spinal cord in people's spinal cord injuries as well. We did mention the brain-computer interface a little bit. Mike Urban is actively working in that area in our lab, as well as George Wittenberg. They're taking a sort of an alternative approach, using vagus nerve stimulation and using that to see if people can regain motor control or motor learning after stroke, and as well as in spinal cord injury. We have some other tools we're developing to make this portable systems so it can be used without having to come to a laboratory or a clinic. I hope to be able to share more on that in the future. The other challenge we're working on is our pressure injuries or pressure ulcers. Our manual wheelchair virtual coach is a set of sensors based in the seat, and then that can tell whether oddly enough, we don't really have good data for manual wheelchair users on what is an effective pressure relief. So how far forward you have to lean, how far to the left, how far to the right, in order to reduce the risk of pressure injuries. So we've put sensors or load cells on the frame, connected to a single board computer, wirelessly connected to a smartphone or tablet, which connects to the cloud. We do some machine learning, and then we can look at whether people are doing a pressure relief or not. So if you look at the bottom right-hand corner, you can see these are the results of the machine learning of the clusters based on the center of pressure on the seat and the weight on the seat. And the orange, you can see is a left lean. The light blue is a right lean, and the gold is a forward lean. There is a little bit of a cluster here on the center. It's a little bit different, difficult to tell a backward lean, but you can tell that if you look at the weight distribution. So this is the weight on the seat based on the different leans, and how they vary. So, but that combined data can tell us whether a person, what type of pressure relief a person's doing, and if they're doing a pressure relief, moving the center pressure far enough to constitute being a pressure relief. Skip ahead a little bit here.
And so we did a series of experiments to identify that people would use their power seat functions, but not necessarily as instructed. The idea with the virtual seating coach was to use the advances in technology, but first onboard computing, later with a smartphone technology, to provide that coaching in real time, contextually aware, all the time available to the user, and provide that to the cloud, one, so those algorithms could be improved based on what was learned, as well as share that data with clinicians in order to improve their clinical practice and eventually improve clinical practice guidelines. And ultimately the goal is that we use the technology interacting with the user to help the user get the maximum benefit from the technology they're using.
So the interesting about that, we also had people use the talks or the wheelchair comfort assessment, the tool for assessment of wheelchair comfort. We also included some gaming type feedback, so smiley faces like you might see at some traffic intersections, especially in Europe, or in using just a flowering tree to help encourage people, a little bit of positive reinforcement to be compliant. And the nice thing is we were able to, for people who use the technology, and increase their adherence to clinical practice guidelines. In other words, tilt and recline in the proper order, far enough at a steep enough angle, so up to 40 degrees, and long enough to reduce pressure injuries. But some people are just for some reason, for various reasons, are not going to be able to do pressure relief maneuvers effectively. And so we are working on active cushion designs. It's our work with the University of Texas Applied Research Institute. The cushion's here in the upper right. It's a computer-controlled cushion that actually controls the pressure in each one of these cells. We did develop what's called a reference loader gauge that's instrumented to measure that, as well as how people sit on the cushion. It's got internal solid state pressure sensors. So if you look at this graph B that I'm circling now, that's the internal pressure. We mapped that with a pressure sensing mat that's commonly used in clinics, not known as being very accurate, but as a pretty good biofeedback tool. So the internal pressure sensors actually do a much better job. So if we look at the bottom row of images, you can see what happens when a person sits on the chair. You get these higher, relatively high pressures under the ischial tuberosities. That's fairly common. The most common way for passive cushions to address this is to offload the ischial tuberosities, as you can see and C on the lower row of images. But the problem there is it all it does is actually transfers the pressure to the surrounding area, especially if you look to the left and right to the trochanters, causing wounds often in that area. So what we looked at is how do you distribute the pressure maximally over the entire seating surface? And as you can see, we got rid of all of the reds and yellows. Everything's in the light blues and greens and dark blues, which is all within the safe zone, healthy for pressure relief. And then we do that dynamically. So as a person shifts, we shift in order to help maintain stability as well as to maintain pressure distribution. But not all pressure injuries come from the wheelchair, just as not all upper extremity injuries come from wheelchair usage, some from transfers. People sit on other things, such as toilets, or transfer between the driver's seat and the passenger seat, and the passenger seat and the driver's seat of the car. If you look around now, if you start looking at wheelchair users, you see like things like dish towels and pot holders and ace bandages and stuff wrapped around elbows and armrests, because that's another common place to get pressure injuries. So we invented this pad called the On the Move pad. It's got a slick surface on one side. It's got neoprene and foam padding inside the slick surface formed by a pocket formed by the slick surface. It's got a sticky surface or a non-skid surface on the inside. So you can, and it's a neoprene, basically neoprene adjustable sleeve. So you can get around things like a toilet that's in an ununiform shape. You have a slick surface against the person's skin. You have a sort of a non-skid surface against the toilet, so it doesn't move on them when people transfer or shift around. And so we're excited this came on the market a couple of years ago. The license been transferred to a new company, but over 600 people are using them now, helping to reduce pressure injuries on the calves and elbows, as well as on their seated surface. So sometimes it's a fairly simple device that could go a long ways. So you have to look at the whole picture. This is why it's really important to be connected to individuals with disabilities, because they will, so you can learn about what a day in the life is like. When I shift gears a little bit again and talk about our human community research, Dr. DiCiano is an engineer physician that works in her, and we were lucky to get a grant from this Agency on Community Living, part of HHS, and to provide community-based organization support. A lot of this came about, we started pre-pandemic, but really became exacerbated during the pandemic because caregivers needed information, ways to share with one another, to link to each other, to provide support to multiple clients if somebody becomes sick or unavailable. And so we started with this I Am Here, which was based on a telemedicine project for rural health, and then to connect the social workers, case managers, as well as attendants and caregivers with the clients. And then we learned to provide also created apps and deployed apps for caregivers to link to each other, but to support and learn from each other as well. And then learn from some of the apps. So we've got some assessment, self-assessment. We can do assessment by their the person they're providing assistance to. So mindfulness and relaxation techniques, so things like box breathing. And then also a little bit of positive feedback, bringing in a little bit of game theory research as well. One of the challenges I mentioned earlier with wheelchair propulsion and transfers, body weight is a key factor. So you want to keep people from gaining too much excess body weight. Otherwise, it puts more strain on the upper extremities. But one of the challenges is many people with disabilities, especially wheelchair users, only get weighed once a year, even if that often. And so we developed this technology to basically put load cells underneath the bed. I like these two pictures to give you an indication of the quantity and the quality of the devices that we could build as part of our research studies. But and then we put them under the four feet of the bed, and then we use that to measure how much a person weighs. We had to do some machine learning if you've got two people in bed or a person and their dog. But it also gives us a really cool thing. You can see how often people roll over at night. It gives us also an idea of strength, quality, and length and quality as well. We've done some work on a home design modification. Actually, some of our colleagues have created a spin-off of Pearl called the Healthy Home Lab now, and we actually got the opportunity in our earlier research funded by the Department of Defense to develop two homes, the red one on the left and the yellow one on the right, actually with a garden across the street for growing vegetables and things like that. We had to build these homes for the price of what it would cost to build a normal home that would be leased by the military for families of service members to live in. And so one of the great pleasures about this project was the ability to work with Michael Graves, who was an architect laureate for the United States and a person with a disability himself. Unfortunately passed away a few years ago. And but we use all off-the-shelf technology. And one of the nice things in the military is everybody uses a ID card, much like the one I've got here. And so that ID card has an RFID chip. We were able to use that as a way to announce people who are at the door. You can remotely operate the doors and let people in. Multiple lines of ingress and egress, high-low counters, wide doorways, easy rolling surfaces. One of the interesting things is people in the military, they may move so frequently, they need to store all the boxes for their appliances and electronics. So we put extra space in the garage for storing the boxes.
Even in the kitchen, where something as simple as preparing meals can be a real challenge.
This
kitchen is designed for people with Alzheimer's and brain injury.
Dr. Cooper, you're not able to.
Specially designed computer programs.
We're not able to see your screen.
It's us. If you log out and log back in, this happens all the time in my group meeting.
Okay.
Just tell them we're going to leave and come back.
Dr. Cooper, we're just going to leave the meeting and come back. There's a small technical issue.
Yep, I heard that. So.
Okay.
You can go on and play the video.
Are you back? Okay.
Even in the kitchen, where something as simple as preparing meals can be a real challenge.
This kitchen is designed for people with Alzheimer's and brain injury.
This is the queuing kitchen, where specially designed computer programs provide cues or step-by-step instructions for cooking things like pasta.
when I click next, the program will give me my first instruction on how do I get started with making pasta.
Take out cooking pot from the lighted cabinet. Take out pasta from the transparent cabinet. Fill the cooking pot with water from the water faucet. Turn the faucet off. Place cooking pot on the stove. Turn on the stove.
This program is ideal for someone with cognitive or memory loss problems. But for those who need more help, there's this futuristic device called the Kitchen Bot. The Kitchen Bot can turn a faucet on and off. It can also open cabinets and drawers and operate appliances. It's a sophisticated instrument that moves up, down, and sideways, and can be programmed for a specific or a group of functions.
And it's kind of evolving as we collect more data and we're working with older.
And then I mentioned transfers earlier as well. Now we're working on caregiver-assisted transfers using different technology rather than independent transfers. And along those lines, you saw in the early video, we were working on a device that this is our strong arm robotic arm device that mounts to the person's wheelchair. Could be on the left or right side, and go to the back, could be within the footprint of the wheelchair. You could take this with you when traveling to family or friend's house or staying in a hotel. And you could drive it off the chair and also put it in a case. So it reduces the footprint of equipment that needs to be in a bathroom, for example, or in a bedroom. It doesn't need to fit underneath the bed like a lot of lifts, which causes problems as well. And you still have to put the sling underneath the person, but there's no awkward lifting or bending. But I'm really more excited about this work we're doing now, where we're getting rid of the sling and getting, so you can do no lift transfers. So we've converted this power wheelchair to be more a robotic wheelchair. Jessica herself is a power wheelchair user and person with disabilities, one of our alumni. And then we modified a hospital bed. You'll see, so we can have the wheelchair basically fall back into the bed, and then added a conveyor to the bed. And so as the person we do that so you try to reduce any shear when the person's being transferred on the seated surface. And then the caregiver doesn't have to lift the feet, but it's a little more comfortable so you don't drag the heels over the leg rest. And it's all basically controlled with a tablet or a phone. And a person can go back in the chair as well. It's a reversible process. We're working now, this is what we call a group 2 chair. We're working with a group 3 chair, group 3 sport chair, which is one with power seat functions. And that'll be a tremendous benefit. The cool thing is the engineer working on that is actually from the intended user population. And so I mentioned we're working on transportation as well. We've done some large surveys of over 1,000 people. There is some interest in self-driving vehicles and autonomous vehicles features because what happens today is most people reduce their day-to-day travel. They ask others for rides. They limit their time of day, or they just give up driving. And actually, very few people use public transportation or systems like Access, special transportation services. So we really have to solve this problem if we want to improve healthcare for individuals with disabilities and older adults, and improve employment opportunities, and as well as educational opportunities. At least there is some work on autonomous vehicles going on in the commercial sector. Some of these technologies are currently available in cars and other motor vehicles that people can purchase today. We are working on that. We're also working on new docking systems and occupant restraint systems because these are also areas that people have identified in need of improvement, especially when we go into more autonomous systems. And then we're very engaged with how to design new electric vehicles. If we have time, we could talk about some of the problems, but they present some significant challenges to individuals with disabilities moving forward. We did a meta-analysis in a comprehensive review and found there's very little knowledge about transportation for individuals with disabilities. Mostly the literature is focused on older adults. We look at journey mapping, so basically interviewing people about their top barriers. Those things that people have to consider when planning or conducting a trip, or what type of assistance available, finding accessible or suitable parking spaces, and then access to a service location. So like public transport, paratransit to connect to something else, and the quality of the transportation schedule, the broadness, and some of the barriers are ingress, egress into the vehicle. As you might imagine, wheelchair and person securement. Again, assistance if you have an autonomous vehicle, who's going to provide help with packages, groceries, and things like that, and also connectivity of the various transportation systems. Interesting thing is, ask people who use mobility devices, wheelchairs, walkers, canes and crutches. They prefer to use minivans and cars. Older adults in cluster 2, they prefer they're pretty much evenly split across all different types of devices. A little concerning is that the accessible transportation people are primarily working on, and even automobile manufacturers on minibuses, a light car, or not at all. So there's not good alignment from where the work is being done with the demands from the users. One way we're trying to fix that is if you take a look at the link, you can see a little more information, but we're working on the educational board game. When it's ready, I'd be happy to share it with you and let you try it out. The goal is to teach OT, PT, engineering students about what barriers people face when trying to use transportation, and then also some of the perks and pitfalls to hopefully improve transportation in the future. We'll also expect to use this for newly injured people as well. We're addressing airline travel. It was nice that the Secretary Buttigieg mentioned that in his meeting this morning. This is a wheelchair that we've converted to be a wheelchair aisle chair. That's actually me using it on an airline flight. We made the wheelchair small enough to also fit in the overhead compartment. This will hopefully, and the National Academies came up with a nice report I was able to contribute to. But this should make, at least for some people, flying easier, because you can roll down to your seat, store the chair in the overhead compartments, put the chair back, roll out of the airplane, and put the wheels back on and use it for your everyday use. And then you can reduce the need to have assistance from others, and do fewer transfers, and also reduce the risk of having your chair destroyed. We also are working now on wheelchair securement systems, so power wheelchair users can potentially stay in their wheelchair when they fly. Mentioned a little bit about robotics arm work. Myself and Breland Styler and Dr. Chung and others are all working on wheelchair-mounted robotic arms. As is our case, we also interviewed individuals and then did some journey mapping, modeling with studies with actual users, driving using robotic arms to determine what their priorities are and how the controls should be, what some of the interfaces might need to be, and ahead here.
Research labs. My research project is focused on the performance evaluation and the user interface of the assistive robotic manipulators. So the assistive robotic arms is that a robotic arm can be mounted on the wheelchairs, and that can assist wheelchair users or people with a disability to do some daily tasks using the computer interface. So the reason we developed the interface is that we have tested with the current robotic original interfaces, and a lot of users have difficulty learning those, either memorize the keys or memorize the command or combination of different keystrokes. So the interface we developed kind of reduce those frustration, so they can quickly learn how to control the robot, and they can do the task just within 10 minutes. There was one veteran look at our robot, and he was so excited, and he said, he just pointed to the robot and saying to the caregiver, "That's what I want." So I think the robot would be really helpful for people sitting in a chair and still want to achieve something for their lives.
So the exciting thing is the VA now covers these, and there's and what even more exciting is that German insurance covers them. So the largest user population of wheelchair-mounted robotic arms is actually in Germany, and they have I think close to 300 users now. Also, I just want to point, this is Alec. He's a computer scientist who worked with us who's been working with us on user interface devices. And actually this is in the lower, right below Alex is the CAD model, and then the interface we developed with Alex for Alex. And it helped Alec gain greater independence. So now we're actually looking at how do we do a flexible control authority and vision guided shared control. So, one of the can we label things in people's homes, because that's where they use the devices most, and then that can help identify objects, what they are. It can help the order of tasks, and then we can do state estimation. But users want to remain in control, but they do like the speed that automation helps. So part of the goal is you can have the person initiate control and stop and take over any time. I'm just going to see if I can show you. So I'm just making popcorn here. As you can see, the dispenser, bowl, everything, label. It's still a little bit cumbersome, a little easier than doing everything yourself. But real trick is learning how to do the optimization of user control, revenue control. This is our Meebot. This is Dr. Jung-Bae Kim. It's one of my former students. Worked with Dr. Kandiati. This is climbing and descending ascending and descending an 8-inch curb. You can also see we put the power seat functions in the base, which allows him to have an eye-level conversation, as you can see him talking to Dr. Candiati there, as well as climb curbs and descend and ascend curbs. It's also, you can see Dr. Kim is a high-level spinal cord injury. It's one of my favorite pictures in the lower right-hand corner there. Those are Dr. Jafak, Dr. Kim, Dr. Sivakantan, all former students of mine, all with spinal cord injuries. The MeBot also can level itself on cross slopes and over bumps, which I have a slide to show you here now. So one of the common accidents that occurs among power wheelchair users requires a report to an emergency room is they're going across the street, somebody cuts them off at the curb cut, and so they get one wheel on the curb and one wheel on the street, and then they get dumped into the street. And so we can actually balance left, right, but you can see on the pictures in the bottom, Jessica going over some uneven sidewalk terrain in a local park near us. And then the other one is a ramp transition. So one cross coming down a slope. So here you can see the wheelchair maintains the posture, the seated posture the entire time through the process. This is one of our fun projects. We work with Amazon. Amazon wanted to incorporate wheelchair users and other people with disabilities into their fulfillment centers. And so they asked us to develop a robotic workstation that could go left and right, swivel up and down, and help people with disabilities from a seated position be as productive as their standing employees. And we got to deploy this and study with the employees and prospective employees with disabilities, a lot of wheelchair users and other walking aid users in different fulfillment centers. And then Amazon Sense deployed this and has made nearly 100 of these robots and use them now to create more job opportunities. But also what's cool, like a lot of things have done well, employees that don't have disabilities like to use it because they don't have to stand all day. So you stand part of the day and then they can sit part of the day. I think I'll skip this. We're also working on alternative power sources. So the most common batteries used, lead acid batteries, are rather heavy. Lithium ion, lithium polymer batteries are starting to make an introduction. The only problem is the fire resistance and the limited size of battery you can travel with on an airplane. So we're looking at different battery chemistries, even small generators as a potential, fuel cells, supercapacitors, and even matic power. And so I think in the future, power wheelchairs are going to come with the power source and it's going to stay for the life of the power of the device. You're not going to change them out. If we can make them lighter or better power density, we can entirely change the design of power devices.
And being in a power wheelchair makes it even more difficult. These wheelchairs run on electricity, and when water comes in contact with them, the results can be shocking. So how do you build a water park that all kids can enjoy? That's the question Gordon Hartman had. He runs the world's first accessible theme park, Morgan's Wonderland in San Antonio.
We had to come up with a wheelchair that would allow for it to get wet and still be able to move about through the use of someone's ability to use a joystick.
That's when he discovered the work of Dr. Rory Cooper at the University of Pittsburgh.
Really be revolutionary.
Gordon and I have the same vision. That's a world where everybody can participate together, so that people with and without disabilities are on the same playing field. The idea is that, hey, an air motor with air tanks, if it's feasible, may provide with a much lighter power chair, much more environmentally friendly, that doesn't need to have the batteries replaced.
And from that idea, a new chair, short for pneumatic chair, was born.
The new chair is powered strictly by compressed air. There's no batteries, so that makes it waterproof. We can recharge it in as little as 10 minutes. Unlike current battery wheelchairs that could take up to 8 hours, it could revolutionize the wheelchair industry.
Brandon Davler, a current graduate student at Pitt School of Health and Rehabilitation Sciences, is a researcher studying under Rory Cooper. Their team works out of the Human Engineering Research Laboratories, where they modeled and built the new chair. The chair that makes a challenging trip to the water park, well, fun.
I like to have the freedom to run around.
It was rewarding to see just how he lit up and the enjoyment that he got out of going through the sprinklers and the water.
He wants to be independent. Quite frankly, we let him go for 30 minutes by himself, and that's what he wants.
And Rory thinks children without disabilities who witness this independence will be influenced too.
That's the kind of experiences you want kids to have, so that when they grow up, they don't have those biases, and they can say, "Hey, I've seen people with disabilities do it just."
So the exciting thing about this project is those chairs have been in the water park for 6 years now with minimal or no maintenance, used by hundreds of kids to participate in water activities. We just got a grant to expand that program nationwide, so we're excited. And then also, if you look in the picture in the bottom left, we developed a scooter version that we used in local grocery stores. Replace those scooters in the grocery stores that are lighter, less maintenance, quicker to charge as well. So it's fun to see kids like Sam and others, the hundreds of kids have come throughout the world to be able to participate in water activities that they couldn't otherwise do. We're also now working on kirigami-inspired or origami-inspired design for wheelchairs. So ideas, cool thing, project we're starting with Brazil. You could flat pack the frames of an entire wheelchair in a sheet. You fold it up, and there you have a wheelchair that weighs less than 18 pounds complete. Cool thing is we use parametric design, so each wheelchair we could use standard size, or we can make each wheelchair to each individual. But more exciting, like I showed, we can do in the previous one, we do a racing chair, a hand cycle, basketball chair, rugby chair, all with different models. So you get the person's seat, their dimensions, we pick the type of chair they want, we run it through our software, matches up the CAD model, we cut it out with a laser, we run through our folding software. The folding software tells us what order to fold it in, and then it just spits out whatever type of chair the person wants. So I think this will greatly reduce waste, increase and cost for wheelchair design. Also requires no jigging, so no specialized jigs, because just like when you do an origami swan or something like that, you fold it all up and it locks in place. The wheelchair does the same thing. And I think it looks pretty cool too. Then we're also working on sort of simple sports and recreation devices. A lot of this work being done by Dr. Duvall. The hand cycle pedals earlier, prosthetic cooker, mouse. So to use a computer, to include computer gaming. This is actually Dr. Duvall himself using it. In his power wheelchair to play pool with an adaptive pool cue. We actually developed for the Paralympic curling team, so modified curling sticks, like table tennis, mini golf. So you can actually see in the mini golf, that's kind of fun. Does the on-the-move pads came back, so the individual that we were working with at the mini golf had already purchased the on-the-move pads and was using it to protect his leg from pressure ulcers. We're also excited about getting more people with disabilities into the innovation environment, becoming scientists and engineers. So we've got to contribute to the Success Act, the congressional report, as you can see there. This is an online open access paper if you'd like to read it. Trying to identify inventors with disabilities. We have another paper in review. We just completed a survey of 5,000 people awarded patents in the last 5 years. Trying to get a hold on how many patent holders or recent patent holders are themselves people with disabilities or identify as such. But there's a real opportunity for growth in that area as well. And then, of course, and also important is inspiring the next generation. So work with U.S. Patent Office on the collectible card series, a gaming program, matching the inventor to the invention for little kids, working with the National Invention Convention at the Henry Ford Museum to inspire young people to become scientists and engineers. And then the National Inventors Hall of Fame is also working on a collectible workbook series for young kids. That's me as a superhero. That's kind of a sketch. And then even they did a playing card series. So I wanted to be the ace of spades, but I got the king of hearts. And that's, thank you very much for your time, and happy to answer some questions.
Thank you so much, Dr. Cooper, for this extensively detailed presentation. You did a great job at showing your entire great work through this presentation, and keeping everyone's time respectful. So, would you take in questions through email because we don't have time for everyone to ask you questions right now?
See if any of the students have like one or two questions too. And I want to personally thank you for coming today, Dr. Cooper. I don't know if you remember me, but thank you so much.
Thank you. My pleasure.
So if anyone has like one or two questions for about 5 minutes, we can just take those, else we can wrap it up. I have to go to class, I'm sorry.
Just to know, we also have internships in Hurl in the summer. So anybody that wants to come, just go to our website. There's an online registration. And
we'll promote this. We should promote this.
Yeah, definitely.
I'll definitely put it out on our social media handles.
Yes.
So, Professor, I have recently taken a research subject which is aligned with the machine learning, and I was intrigued by the things that you've built. And I was curious, like how you collect the data. Like, for example, you have made a model which actually captures like the sleep quality for the people who are disabled. So like how do you get the data for that? And actually I wanted to, like, if there is something that I can contribute on and do whatever handful, so it will be really a great opportunity for me.
Sure. We're always looking for collaborators and, like I said, interns and postdocs and students. So those are opportunities. Typically, we have to collect that data. So we literally put the scales under people's beds and collected them for over several days. And then that gave us our data set. So we do a lot of, in-home wearable data, sometimes the robotics data. We had some studies in-home. Sometimes we bring them into the lab, or we pack up our lab and go to consumer events and collect the data there.
That's nice. Thank you so much, Professor. And definitely I would apply on the link. So it's on your personal website, or?
It's on our Hurl website, yep.
Okay.
herl.pit.edu.
Sure, Professor.
Thank you so much, Dr. Cooper, for this and taking time off your busy schedule. And I would like to extend our gratitude from Northeastern as well as Allied. Thank you so much for being with us today. Thank you so much, Valerie, for assisting us today. That's all been goodbye.
Yeah, thank you for the opportunity. Thank you, Valerie. Great job.
Yes, and thank you, Valerie, for working alone for that whole time. That's an impossible task. Thank you.
Bye-bye.
Have a great weekend, everybody.
Have a
great weekend.
Thank you for joining us today. Dr. Cooper's insights into participatory action design have undoubtedly opened our eyes to the transformative potential of inclusive engineering. We hope this discussion has sparked curiosity and a commitment to fostering collaborative environments where every voice is heard and valued. Stay tuned for more enlightening content, and don't forget to like, subscribe, and share. Until next time, this is Allied, signing off.